Okay, welcome to this workshop. So what we're going to do is we've got our program open. We see that we have some mathematical calculations in a routine. Actually, we have quite a few of them in this particular routine. But we're assuming that we don't know the components. We don't understand this full mathematical expression here. So what we're going to do is we're going to find out what is involved in this mathematical equation. So what I've done is I've just double clicked on it, and the expression is actually typed in. If you've never done this with a compute, this is typed in, and you can put together any kind of equation, any kind of expression here, and it will do the math for you. And once the math is the solution for this equation gets put right here in the destination. So we have what the expression is, and the expression could be 1 plus 1. What that solution is at the end of that equation, it's put right here in the destination, which in this case is a first wrap delay pre-time, or a timer, pre-time, right? So that's where it is, a double integer data type, timer, and that's where it's put. The solution for this expression is put right here in the destination. Okay, so we're going to double click on this. We're going to Control A and copy this, right? So we're going to select it all and hit Control C and copy. Then what we're going to do is we're going to go to a website. Let's close this. And this website is a website called Chat GPT, or OpenAI, but commonly referred to as Chat GPT. So OpenAI. If you just type in Chat GPT like I did here, then what you'll have is this introducing Chat GPT website we just left, and we're going to go back to. You'll sign up for an account here. The account is free. Okay, once you do that, you'll enter in to the inside of Chat GPT. Now this is an account where my co-workers, my wife, we've done all kinds of tests and playing around here. So when you've asked a question, which is down here, and it provides an answer, as you'll see, it will keep a record of what you've asked. Okay, so we've between the guys and the family, we have asked all kinds of crazy questions. Some of them, hopefully, some of these won't be embarrassing to me. But okay, so needless to say, this is what we're going to do. So what we're going to do is right here in this section, we're going to go ahead and paste our expression. We're going to go back to the beginning, and we're going to ask, could you solve and explain in detail this expression? Okay, and we'll put it there. We'll put a question mark. Let's see, at the end, and then we'll tab over, and all you do is hit this little head here, this little arrowhead. That's probably more of a flat plane, little airplane, but you just put that in there. Now, this is Chat GPT. This is artificial intelligence at work. You're seeing it. If you've never seen it before, never used it, this is artificial intelligence. And we're going to get into this, and we're going to dig a little bit deep into it, and that's what we want to find out. So now what it's doing is it's breaking down each section of this expression. So 1 divided by the motor speed, storage area, element 0, times drive ratio divided by 1,000, divided by the tube diameter, divided by 12 times 3.14, divided by 60 times 1,000. That is our expression. It's a lot there, right? So with the motor speed storage area, part of the expression is referring to the value stored in the array variables. Okay, motor speed storage area. The 0 indicates that we're interested in the first, i.e. index 0 value in the array. With more context, it's hard to say what this value represents, but we'll assume that it's a numerical value. There we have is the typical dog in the background. Let's see if I can't, seems like every time we do a recording there's a dog in the background. It's kind of funny. All right, so back to where we were. The 0 indicates indicates what we're interested in. The first, the 0 in, value in the array. Drive ratio divided by 1,000. Next part of the expression is a calculation involving the drive ratio. We're going to dig into that. We're dividing the drive ratio by 1,000, again without more context. Then we have the tube diameter divided by 12 times 3.14. Now, this is an important part of what we're going to dig into as well. This part of the expression is also a calculation. We're taking the value of the tube diameter and dividing it by 12, presumably to convert inches to feet. Now we know the tube diameter divided by 12 is the inches to feet. Okay, then we're going to multiply that. When we're then multiplying the result by 3.14, which is a short version of pi, which is an approximation of mathematical constant pi. The calculation appears to be related to the circumference of a circle, which it does in this case, which suggests that tube diameter is the diameter of a circular object such as a pipe or tube. Then we're going to divide that by 60. After calculating the circumference of the pipe, then we're dividing by 60. It is likely to convert the units of feet per minute to units of feet per second times 1,000. Finally, we're multiplying the entire expression by 1,000, again without more context. Hard to say why this multiplication is necessary, but it's possible it's related to converting units or scaling the result. So putting it all together, right? Motor speed area, calculation involving the drive ratio, the circumference or circular object with a diameter specified by the tube diameter, and a conversion factor from minutes to seconds, then multiply the result by 1,000. Okay. Now we happen to know a few things. What would the solution, oh boy, I'm all kinds of, I got a new keyboard. So what would the solution, and in this case we're looking for a solution or an answer, okay? That is typically an expression, the result is referred to as a solution, okay? I hope that it makes sense. What would the solution be if so we're going to put a little more context here. If the motor speed storage area bracket 0 bracket is 150, in this case RPM, okay, and the tube diameter is 22.009. Let's add that in there. Inches. All right, to the, okay, so we'll let it, I was going to put to the expression above, but it knows that it's going to take information from the top and it's going to add the information that I just added, and it's going to combine them and then come up with a solution. That is the intelligence part. It doesn't start with not retaining any information that it already had, which is, and to me, is brilliant. It's sort of like having a conversation with someone, and you mention something, they mention something, you go back to mention something again, they retain that part, and you add to it, and it continually adds and adds and adds until you come up with the solution that works for you, as you'll see. So sure, let's plug in the values and calculate the result. So it remembered the expression I gave it earlier. I added new information, and then it came up with a tighter, closer solution. We don't have the drive ratio, so we'll have to leave that part of the expression as it is. That's true. But 1 divided by 150 times drive ratio times 1,000, 22, and it goes on with the expression. Simply the expression, we can calculate the expression within the parentheses first, and it gives us an answer, 5.1123. Now, since it doesn't have the drive ratio, then it's not sure what the solution, the real solution would be. But it does come close based on the data that we've given it. So it gives you the expression, right there. Now, the only expression that it's saying it doesn't really have at this point to come up with a complete solution is the drive ratio. So this final expression cannot be simplified any further without additional information about the value of drive ratio. However, we can see that the result can be a value in units of feet per second multiplied by 1,000. Okay, so now we have some info, and we are starting to understand how we could use artificial intelligence to help us break down and understand a very complex mathematical expression. And we see how this is used. It's a compute. So we have an expression here, and then we have a destination. We also have a tool that can help us break down that expression, make sense of that expression, and give us an accurate solution. Okay, so let's look at drive ratio. What do we need for drive ratio? What is it that we need? What can we find out? So let's, oh, we don't want to edit, actually. That's not what we want. Drive ratio, we want to cross-reference that drive ratio. What is the difference? What is the information, I should say, that we need for the drive ratio? Okay, so let's take a minute and take a look at this. Okay, so what we've done a cross-reference, and we found that our current drive ratio is 1135. So we do have another piece of the information. Now, what we're going to do, though, we say, okay, drive ratio, I got a number. This is what's in there. All right, source A, source B, add a 1 to it, puts it in the destination. Pretty simple. But what is a drive ratio? In the expression above, what would a drive ratio mean, or how does it work? Can you explain? All right, so we're going to say, explain to me what a drive ratio is, because I may not know. Okay, and then it's going to, based on the information in the expression above, what would a drive ratio mean? And then we'll give it the answer, a part of the information, new information that we have. So in this case, certainly, drive ratio mentioned above refers to the ratio of the number of rotations of one part of a mechanical system to be the number of rotations of another part of the system. So in this particular case, we have two cylinders, and they need to be geared, and they need to drive at certain speeds. So if the first one, which is the end, drives too fast and you're pulling paper across it, and it's actually pulling that paper, if it goes too fast and the one behind it goes too slow, you'll rip the paper. If the front one's going too slow and the back one's going too fast, then you'll bunch up the paper. The front one will not be pulling fast enough. So you have to have a mathematical ratio that will keep these two geared, if you will, to the same speed. So as they accelerate and decelerate, they accelerate and decelerate with the same mathematical equation. Okay, two different motors, two different drives. They've got to be ratioed and geared the same, or you're going to have problems with your paper. I hope that makes sense. The ratio can be calculated by dividing the number of rotations of the input by the number of rotations of the output. For example, the drive ratio is 5:1 because input motor rotates 5 times for every 1 rotation of the output gearbox. Now that's mechanical gear ratio. Okay, and this expression provided, the gear ratio is divided by 1,000, which suggests that it's being used to scale the value in some way, perhaps to convert between units or to adjust for the particular mechanical system. Okay, so now what I'm going to say is, okay, the current drive ratio is 1150. What does that tell us? All right. Okay, now we do know that it's 1150 because we have it right here, or 1135. That's pretty close though. But what is that telling us? Okay, drive ratio is 1150. It means that for every 1150 rotations of the input, the motor, the output, the gearbox or wheel, rotates once. Interesting. In the context of the expression provided earlier, the gear ratio is being divided by thousands, which suggests the expression is assuming that the drive ratio is specified in units of per thousand. For example, if the drive ratio is 1000, then it would mean that the output rotates once for every 1000 rotations of the input. However, since the drive ratio is actually 1150, the actual ratio being used in the expression would be 1 to 15, i.e. 1150 divided by 1000. 1.15. Okay, now we got a little bit further ahead. So let's look at our program again. So that's our drive ratio. Okay, what's determining that 1135? Okay, we kind of have that answer here, right? So if the current drive ratio is 1150, it means that for every 1150 rotations of the input, the output rotates once. So I put 1150, but it's actually 1135. Okay, so now so we're entering that drive ratio, okay, through our panel view. All right, so the operator is entering a drive ratio in there, and I believe they're entering a percentage, but 1135 is the drive ratio. So there's going to be some sort of scaling that they're going to do off the top of their head, off of a sheet, some sort of documentation or some sort of percentage assumed to determine what that drive ratio is. Okay, now I don't know what that is off the top of my head. I'd have to dig deeper, but we do know that it's an entered piece of data. That's important. All right, now a couple of other things to consider in this equation, right? So we have our speed, we have our drive ratio, which is a data piece entered. We have an equation here, a constant of 1000, right? So that would determine how many revolutions, right? And that would lead us to our encoder. We'll get to that in a minute. We have our tube diameter, and we're breaking it down here, the diameter divided by 12 in inches times pi, okay, divided by 60 times 1000. Okay, so we have some of this, but let's look a little deeper. Okay, so in our let's see if we can get this up here. Our encoder ratio, all right? So our drive ratio and our encoder ratio, two different numbers. So all these are part of what we're working on. So we have our craft position essentially, but we have our scaling for our encoder. All right, so we have an encoder put in here into our program, and we have 1892. Okay, so in our program we have 8,192 pulses per revolution. Okay, 8,192 pulses per revolution. But let's look at something here. So I know what the encoder is on this one, okay, in this particular project. Let's go up here. All right, it's an 842E-CM absolute integrated motion encoder. Okay, so now we have the manual here. All right, let's see here where I have that information. So in this installation instructions, what we have here is we're talking about pulses. It's not using pulses, number of revolutions, maximum, and resolution. Now often you'll hear talk about resolution and number of revolutions. Okay, so we have up to a resolution of 18-bit 262,144. Number of revolutions max. So we are using this number right here, this 4,096 revolutions or pulses per revolution. Now, if we look at this and we in our program, we see that we have 8,192. That's right about, almost exact, the amount of revolutions doubled. So for every turn of our drum, we get 8,192. So it'd be 2 full revolutions of the encoder, okay, for every drum turn. So we have 8,192 pulses per revolution, okay. So that is our encoder ratio, right? And currently, when we stop this program, we have 434 in our encoder ratio. So we have our encoder. We know how many turns is in our encoder. We know what's involved with our, let's go down here and see if we can find our expression. We know what's involved with our drive ratio. Okay, so we have pretty much everything we need here, just about. Let's see. So the drive ratio is 1150. Okay, so then if our expression, let's go up here and get our full expression, right? We're going to copy that. We're going to come down here and we're going to say if, let's just say, please solve this equation. Okay. We know that our 150 is the motor storage area, I'm going to put down the motor storage area. Let's do that. Well, the motor storage area is 150. The drive ratio is, what was it? 1135, right? 35. And let's see what do we got here? What's the next piece? Let's fix that. 35, and the tube diameter is 22.09. Okay, so I've asked it to solve the entire equation with all of the information, and we're going to let it do it. We pretty much have the answer, but this is going to give us a start to finish solution. And then we're going to have all of our information. Now, if you're missing any pieces of this, what I would recommend you do is do this, or we'll do it. We'll just do it. Okay, so motor storage area is the speed. We set the speed at 150. Drive ratio, we've already talked about what that is. So we're trying to set a ratio that's equal between the two drives, so that the cylinders turn within a near identical ratio, okay, to each other, or we'll rip or bunch the paper. Okay, so that's what our drive ratio is answering. The tube diameter, 22.09 inches, divided by 12 times 3.14. So right there we've got a mistake. That is a mistake, and we will not get that correct answer, okay, because we have that mistake. It's divided by 12 times 3.14. So let's go back up here. Let's get our expression once again. And these are the things you're going to have to pay attention to when you're working with artificial intelligence, a Chat GPT. You're going to have to double check every single thing that they do. Okay, trust me, you're going to have to do it, because if you do not, let's see, did it solve? Oh, it does have it right there. So 12 divided by 12 times 3.14. Okay, I have found that on a couple of occasions when I first did this that it would not multiply the tube diameter divided by 12 times 3.14. In this case, it looks like there seems to be missing multiplication. There it is, between motor speed. So I assume that the correct expression is, and substituting in the given values, it did it. It fixed it. Good. 150, 1135, 2209, 12 divided by 12 times 3.14 divided by 60 times 1000. Simplifying the expression with the parentheses. 150, substituting this back to the original expression. Therefore, the result of the expression is approximately 317.20. Now, the big thing here is taking an expression from your from a program, using Chat GPT to solve it. Now, even more importantly, where's the drive ratio come from? What does that mean? Okay, tube diameter divided by 12. Why? Let's do this. I want to do this. I want to help you even further understand how to use this tool. What am I solving by calculating okay, so it's going to tell us what we're trying. Why would somebody put that in an expression? When you divide 12 tube diameter by 12, you're converting the diameter from inches to feet. Now we know exactly what we're trying to solve with that part of the expression. Okay, then we say, okay, why are we calculating the solution let's get this, calculating the solution by pi. What am I trying to do by calculating pi in this solution? Okay, the mathematical constant used in the expression you provided, because it is necessary to calculate the circumference of the tube, which is given by the formula. Circumference equals pi times the diameter. Here, the diameter is inside diameter of the tube, which is divided by 12 to convert from inches to feet. Once we have the circumference, we can use it to calculate the fluid velocity of the tube in the tube, which is an important parameter in many fluid dynamics calculations. Okay, let's move past some of this, specifically the expression. Let's break it down. Here the diameter is, again, the inside diameter of tube, which is being divided by 12 to convert from inches to feet. Okay, so the area equals pi divided by 4 times the diameter of tube. Okay, by combining these formulas, we calculate the fluid velocity in the tube. The expression to provide is one way to do this, using the given values of the motor speed, tube diameter, and drive ratio. The fluid velocity of the tube, and we need to be able to have that to be able to, so here specifically the expression you provided is calculating the fluid velocity in the tube based on the given motor speed to a diameter and drive ratio. The math that you need to balance out the speed and velocity, or velocity of our cylinders. Okay, we're taking all of this information because these cylinders are turning, there's gear ratios, there's a whole bunch of mathematical calculations. Now you can further break this down to really break it down, even to get a better understanding, if that's what you choose to do. Okay, if the fluid velocity, you don't understand that part, then you can say, please explain in basic terms fluid velocity in the tube. All right, what does that mean? What do you mean fluid velocity in the tube? And it will tell you what that fluid velocity in the tube is. Now, when I first did this, I'm going deep in over certain points of this calculation that I didn't do before, but I'm just sharing with you how you can use this tool to break down an expression even further so that you thoroughly understand each piece of the expression. You're not just doing it and thinking it's going to come up with the solution, right? So we have to know what our speed is, our motor speed is, which is the motor speed storage area. We're storing that speed there. We have to know what our drive ratio divided by 1,000. We got to know why we're dividing it by 1,000, okay? Which it talks about right up here, right? So it discusses what that drive ratio divided by 1,000 means. We need to understand, what are we doing with this part of the expression? 2 diameter times 12 divided by, or multiplied by 3.14, and the rest of the expression divided by 60 times 1,000. So if you run into, in short, if you run into an expression and you do not understand what that expression is, pull up Chat GPT, sign up for an account, and then work with it and have it work through the solution with you so that you thoroughly understand each part of the expression. All right? This is what I wanted to share with you. There's so much more we could do with this, but this is a good introduction to it. And we're using a real world situation here. This is a real world expression on a project that I'm working on. And this is a real way that you could, let's see, where am I? Right here, that you could work to begin to understand what that expression's trying to solve. That's going to be important as you work as a controls engineer with complex programs. All right. I hope this is helpful. I look forward to hearing your feedback. Talk to you guys later.